Hello everyone, I'm Changhua and these are my group mates Changjun, Li Guang and Melvin. Today we are going to talk about the Parallella Project. Do you know about the Parallella Project? How to build a parallel computers? What are the parallel applications? And how is it important in the future? Today our team will answer this question to you. The Parallel Project is actually a community-driven parallel computing project. The Parallel Project is based on 3 key points: open access, affordability, and open source.
Hello everyone, I'm Changjun. Now I'm going to talk about the Parallella platform. The Parallella platform is an open source, energy efficient, high performance, credit accessed computer based on the Epiphany multi-core chips developed by Adaptava. This affordable platform is designed for developing and implementing high performance parallel processing applications developed to take advantage of the onboard Epiphany chip. The Epiphany 16 or 64 core chips consist of scalable array of simple RISC processors programmable in C or C++, and connected together with a fast on-chip network within a single shared memory architecture. This picture shows an implementation of the Epiphany architecture. There are 4 key components for this Epiphany architecture. Firstly, a superscalar floating-point RISC CPU in each mesh node that can execute 2 floating-point operations and a 64-bit memory load operation on every clock cycle. Secondly, local memory in each mesh node that supports provides 32 bytes of sustained bandwidth and is part of the distributed shared memory system. The third part is multi-core communication infrastructure in each node that include a network interface, a multi-channel DMA engine, multi-core address decoder, and network monitor. Lastly, a 2D mesh network that supports on-chip node-to-node communication latencies in nanoseconds with 0 startup overhead. Next slide I will talk about how to build up a parallel computer. This picture shows a list of the major components. Dual-core ARM-A9 CPU, 16 or 64 core Epiphany multi-core accelerator, 1 GB RAM, micro SD card, 2 USB 2.0, 4 general purpose expansion connectors, 1 GB Ethernet, HDMI port, Linux operating system, and lastly is 3.4-inch x 2.15-inch form factor. The 66-core version of the Parallella computer delivers over 90 GFLOPS on a board the size of the credit card while consuming only 5 watts under typical workloads. For certain applications, this will provide more raw performance than a high-end server costing thousands of dollars and consuming 400 watts. Next on, I will pass to my groupmate Melvin to talk about parallel application.
Hi, I'm Melvin and I'm here to talk about the parallel applications. There are a total of 5 types of applications under parallel programming. Firstly, Erlang, Go language, NumPy, SciPy, Hadoop, and MPI-like. 5 of these are accelerator support applications which does support for many core accelerators. Firstly, let's talk about Erlang Many-Core Accelerator support. Erlang Many-Core Accelerator support does significant boost as a high-performance computing language framework. Thus, it will allow tasks to be offloaded from the host processor to many core accelerators. Language used in this accelerator support is C, C++, and Erlang. Next on, I'm going to talk about Go Language Many-Core Accelerator Support. Go Language Many-Core Accelerator Support does significant performance, energy efficiency boost for applications, thus allowing Go applications running on the host to offload tasks to many core accelerators. Language used here is C, C++, OpenCL, and Go. Next on, I'm going to talk about NumPy, SciPy, many core accelerator support. NumPy, SciPy, many core accelerator support does significant performance boost for Python high performance computing applications. It will allow Python applications to offload NumPy, SciPy functions to many core accelerators. Language used here is C, C++, OpenCL, Python, and NumPy, SciPy. The fourth accelerator support I'm going to talk about is Hadoop. And Hadoop does significant performance, energy efficiency boost for applications built using the framework, just like Go Language Many Core Accelerator support. It does offload of MapReduce operations from Hadoop applications running in a JVM on the host processor to many core accelerators. Language used here is C, C++, Java, OpenJDK developments, Hadoop. Last but not least, I'm going to talk about MPI Lite. MPI Lite is MPI for many core accelerator support. It is used with massively parallel systems made of processors with a small amount of local memory. This is built on top of OpenCL as a lightweight messaging passing framework that is suitable for use with many core accelerators. Language used here is C, C++, OpenCL, NPI, or similar messaging passing framework. This will result in significant performance, energy efficiency boost for applications. These applications will use the Parallella hardware platform for many core programming infrastructure as a test and development vehicle. Next on, I'll pass to Changhua for his concepts.
Hi, I'm Changhua. The topic that I will be elaborating on will be the concepts behind the Parallella projects. For concept-wise, it's basically split into two components where it's mainly talking about the limitation of current technology, where problems or rather issues will arise in the near future. This is where the advancement from current technology will come in. The second component would be about the usage or availability for the public as well as the professional, as many of them are actually in need of such technology that is within reach in terms of size of hardware as well as the price. As we can see from the chart, it is actually showing us the progression of our currently technology architectures, where it is actually slowing down by a lot towards the end. This implies that the improvement in our current technology is not sufficient enough to see a big improvement in performance. This in turn leads to the other three problems that are memory bandwidth issues, programming issues, and scaling issues. In terms of memory bandwidth issues, it is because of the performance improvement is not matching up with the demands from program application, and thus it will cause a bottleneck in the memory. As for the programming issues, it comes when we need to adjust our programming according to how the current technology is. Lastly, for scaling issues is because for the current serial architectures, the problems are usually not in scale with the performance. Thus, the Parallella project aims to implement and improve on the current serial architectures. Next, we will talk about public and professional usage. Basically, in terms of current parallel computing technology, it is not readily available and also expensive to the public and even for the professionals. Thus, Parallella project aims to come up with the technology and hardware at a cheap pricing and also to release the SDK so that everyone out there is able to make their own changes to the programs. So when that happens, many people will be able to get the technology and thus be able to process more information and develop better applications and programs. Lastly, I will pass on to my last teammate Li Guang to continue to share more information related to the Parallella project.
Hi everyone, my name is Li Guang and I'm going to talk to you about the future of the Parallella project. With the pioneer batch of Parallella boards being already shipped out, and with so many language and platform support being planned, Here are some interesting projects being developed on the Parallella platform. Firstly, development will be done on implementation of a software-defined radio. This includes current projects that are being developed on the Parallella website itself, including the GNU radio scheduler for many core accelerators, GNU radio DSP block porting, as well as an OpenBTS DSP many core accelerator. The platform can also be used for research purposes, such as the development of artificial neural networks to take full advantage of the chipset's parallel computing capabilities. Lastly, we will also see development on the Parallella chipset for its use as a graphics processor. This wraps up our video on the Parallella project. We hope you enjoyed it, and if you are interested, you can visit the Parallella project's website at www.parallella.org. Thank you.